And welcome to Otten Math. In this edition, we're going to talk about systems of equations, and we're going to solve a couple problems involving systems of equations. The first problem, we have a triangle ABC, where A is at 5, -1, B 1, 1, and C 5, -11. And we're trying to find the length of the altitude from A to segment BC. So this is a multi-step problem. Let's draw it out. First thing I do is I graph out my triangle. I have B at 1, 1, A at 5, -1, C at 5, -11. And we're trying to find the length of the altitude from A to segment BC. So what we're trying to find, really, I'm going to identify this point as Y, is the altitude from A to Y. So there are a bunch of things we need to know in order to figure this out. The first is we need to find out the slope of BC. Once we have the slope of BC, we can figure out the slope of AY, because we know that AY, the slope of AY, will be the opposite reciprocal of the slope of BC. Once we have the slope of BC, we can figure out the equation for both AY and BC. And then after that, we'll find the point of intersection between BC, and AY. Once we have that point, we can use the distance formula to find AY. Okay, so here we go. So the slope of BC is going to be 1 minus a minus 11 over 1 minus 5. That gives us a slope of -3. So we know then the slope of AY is the altitude to BC needs to be the opposite reciprocal. So what we mean is we need to have the opposite sign of BC, and then AY will also have the reciprocal, or the slope will be the reciprocal of BC. So the slope of AY must be 1/3. Next thing we're going to do is we're going to write the equation for AY. So we use our point slope form. Y minus y1, which in this case is -1, is equal to the slope times x minus x1, which in this case is 5. So I have a point in point slope form. I have y minus 1 is equal to 1/3 x minus 5, or y is equal to 1/3 x minus 5/3 minus 1, and to simplify that even further into slope-intercept form, I have y is equal to 1/3 x minus 8/3. So that's my equation for a segment AY. Next, we're going to find the equation for BC. Again, we take the slope of -3, and we can choose either B or C as our point. We write it out in point slope form. In this case, I'm going to choose B. Y minus y1 is equal to the slope, or -3, times x minus x1, which in this case is 1. I rewrite it in slope-intercept form, and I have the equation y is equal to -3x plus 4. Now I have these two equations for these two segments. I'm going to set them equal to each other, or substitute the values of y for each equation, and then solve for x. So from the segment BC, I have the value of y, which equals -3x plus 4. And from the segment AY, I have the value of y, which is equal to 1/3 x minus 8/3. So I set these two values equal to each other because y is equal to both of these, and I solve for x. So I get 10/3 x is equal to 20/3. And then I realize that x is going to be equal to 2. Once I have 2, I can plug it back into either equation. In this case, if I plug it back into the equation for the segment BC, or line BC, I get y is equal to -6 plus 4, so y must be equal to -2. So now I have the coordinates for y. It's 2, -2. So now I'm going to use the distance formula to solve for the distance between A and Y. I have A as a point. I have Y as a point. So here's Y. Now I need to use the distance formula to solve for the distance between A and Y. So the length of the altitude will be 5 minus 2. Okay, so we had 5, -1 as a point for A, 2, -2 for the point for Y. So 5 minus 2 squared plus -1 minus 2 squared, which gives me 9 plus 1, which gives me a distance of the square root of 10. So in case you got lost, the value or the coordinates for A were 5 and -1, and the coordinates for y were 2, -2. So you see the distance formula is x2 minus x1 squared plus y2 minus y1 squared, and then you take the square root of that value. That gives you your distance. In the next problem, we're asked to find the distance between two parallel lines. One is y is equal to 2x plus 3, and the other is y is equal to 2x plus 7. So if you recall the slope-intercept form, y is equal to mx plus b, where m stands for the slope and b stands for the value of y in the y-intercept. We can see that the slope is the same, so they're parallel lines. One line intercepts the y-axis at 3 and the other at 7. So the first thing we do again is to graph our two lines. Y is equal to 2x plus 3, and the other is y is equal to 2x plus 7. And then we need to choose a point, and it doesn't really matter which point we choose on either line, but let's make it easy on ourselves. We're going to make sure that one of the points is going to be 0. So I'm going to select this point, and this point is going to be 0, 3. And then we're going to draw a line here that's perpendicular to y is equal to 2x plus 7, because we know the shortest distance between two parallel lines is a segment that is perpendicular to both lines. And so we're trying to find that distance, and that's just assumed from this problem. So we need to figure out what that point is right there. So we know again that the slope of this line, let's just call it A to B for now, the slope of A to B is going to be a slope which is the opposite reciprocal of the slope of y is equal to 2x plus 7. So we know our slope is going to be -1/2. Okay, let's continue on. I've completed this problem, so let's talk about what happens here. So I have a slope of -1/2 for the line, the blue line, and now I want to find the point of intersection. So the first thing I need to do is I need to figure out the equation for the slope of the blue line. It's going to be y minus y1, or 3, is equal to the slope of the blue line, which we discovered as -1/2, is equal to -1/2 x minus 0, or the other value for x here. Writing that in slope-intercept form, I have y is equal to -1/2 x plus 3. And then I take that and I set this equation, or this right half of the equation, equal to the right half of the equation for the line that it's intersecting. Y is equal to 2x plus 7. So I have -1/2 x plus 3 is equal to 2x plus 7. Or 2.5x, if I add half x to both sides and subtract 7 from both sides, I get 2.5x is equal to -4, or x is equal to -1.6. Next up, I need to find out what the value of y is. So I can plug in my value of x into either equation to find out the value for y. So I plug it into my blue line, and I get y is equal to -1/2 x, or -1/2 times -1.6, because that's what we discovered x was, plus 3, and I find out that x is now 3.8. Last step is to find the distance between 0.03 and -1.6, 3.8. So I go back to my distance formula. Distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And by the way, it doesn't really matter if it's x1 minus x2 or y1 minus y2. You can mix these up. You'll come out with the same answer. Or the distance is equal to 1.6, which was our value for what we had originally called b, x value, or x coordinate, minus 0, which was the x coordinate for the A point, plus 3.8 minus 3 squared. I take the square root of those values and I get 1.8 units. And that's your distance between A and B.